This is problem number 4. The problem says, which of the following sets of quantum numbers, n, l, and m sub l, are not allowed? And then it gives 5 sets of quantum numbers, which I've already written down on the board here. And the goal of this question is to figure out which ones can't exist. So, just an overview of the basic rules here, real quick. N is going to be some number. That's the first number in the set. Okay? The second number in the set is going to be L. And that's basically, the L's can be anything up to n minus 1. So L can be 0, it can be 1, leading up to, all the way up to whatever n minus 1 is. 1 less than n. And finally, m sub L, that's the third number, and that's going to be equal to negative L, anything from negative L to positive L. So you'll have negative L plus 1, negative L plus 2, all the way to positive L, basically. Okay? So let's just examine the sets one by one, and then we can figure out which ones are allowed and which ones aren't. So this first one, the first number is n, which is 3 in this case. So that means that L can be, what's n minus 1 then? 3 minus 1 is 2. So that means that L can be any integer from 0 to 2. So 0, 1, and 2. It seems to be fine. 2 is in the set of 0, 1, and 2. So then m sub L can be any integer between negative 2 and positive 2, since L was 2. So in this case it's negative 1, that's fine, because m sub L can be anything from negative 2, negative 1, 0, 1, and 2. Okay? So this one's okay. Our next set is 2, 3, and negative 1. So n is 2, which means that, so L, the maximum value of L is n minus 1. So 2 minus 1 is 1. And L can be, so L can basically be any number from 0, between 0 and 1. In this case it's 3, so these quantum numbers are invalid. Okay. Set C. We have, the first number is n, it's 3. So that means that L can be any integer from 0 to n minus 1, which is 3 minus 1 is 2. So 0, 1, or 2 are the choices for L. In this case they put 0, that's fine. But what does that mean that m sub L has to be? Well, m sub L is any integer from negative L to positive L. In this case, L is 0, which means that m sub L can only be positive or negative 0, which is just 0. So it can't be 1, so this set is also invalid. Okay, let's check out set D. They've set n equal to 6. L is n minus 1 is 5, so it can be anything 0, 1, 2, 3, 4, 5. It's 2, that's perfectly okay. 2, so that means m sub L can be anything from negative 2 to 2. It's negative 1, that's fine. A is good. And finally E. So they've set n equal to 4. L has to be n minus 1, which is 3. They've put it as 4 here, so this set is no good. So once again, the question asked, which of the following sets of quantum numbers are not allowed? So the answer is B, C, and E are not allowed, and that is option 2 on the test.